Okay, so now I want to talk about arrays in MIPS, specifically integers of array of integers. So the following program, what we want to do, I want to create an array, and then I want to get numbers to the array from the user. After this, I want to sum the numbers in the array. So the user will insert numbers to the array, and then we will sum all the numbers in the array that the user inserted. Okay, so create an array, get input from the user to the values of the array. The user will also define what is the size of the array, insert number to the array, and in the end we will sum all the numbers in the array, the numbers that the user inserted. So we will start again with the data. We will have here prompts, and we will define here the spaces for the array. So we will define array of integers, so we'll use word. Remember that using int, each cell will be 32 bits. Now, or it's word, okay. Now, the array space will be, let's define 100 words for it, so the user will be able to define until length of 100. It can be less, but the maximum that we will store, so it's array of up to 100 integers. And again, integers are stored at 32 bits each. Now the prompts. Okay, so prompt 1 will be, okay, ASCII, and what it will say is enter the number of elements in the array, and we can do up to 100. Prompt 2, again it's ASCII with a null terminator. It will tell the user to enter element, and it depends on the element it will be. In the running time we will define here which element we are dealing with. The next one is just a string for doing the colon, which is this one, because in the runtime we will say enter element 4 colon, and that's it. So let's even do here a space. Next, the results. We have one results which will tell the user here number of elements which the user inserted, and we will tell the user result 2, we will tell you the sum of the element, which is \n sum of elements. Okay, this is what we will need. We will need the array that we defined and the prompts. Now let's get to programming. So global and main. Okay, so let's start with getting the size of the array we want to work with. So prompt ask the user for number of elements. So in order to do so we'll use the v0 with order 4 to make a prompt, and we need to load for the register that write, which is a0, the prompt we want to tell, which is the prompt 1, which is the prompt that tell enter number of elements in the array, and we want to print it. And I will do it now, exit program, in order to the program not entering a loop or something that is not never end. So let's exit the program. Just let me remember how how you exit, which is which v is, yes, it's 10. So li v0 10 will exit the program. So just do syscalling will exit the program. Let's just see what I want to see until now is just a prompt that tells me to enter to the array, and that's it. So let's see if it works. Enter the number of elements in the array, and this is it. Good. We did a prompt, we saw that it's working. Great. Now let's continue. We need to read numbers. Read the numbers of elements. And we will save the number of elements to the register as 0. So to read, we are using, to read a number, integer, we're using li v0 of 5, and we use syscall, and this is getting into v0. So let's save it because we will change v0. We will save it to s0, so move s0 and v0. Okay, so store number of elements in array in s0. Okay, so s0 number of elements in array. Okay, now I need a loop. I need a loop for moving on the number of elements the user inserted, and for each one of them getting a number and insert it to the right place in the array. Now remember that each cell in the array is 4 bytes, and what we will do, we will look at the first cell and we will jump to the correct cell using the counter. For example, if we want the second cell, what we will do is we will multiply by 4 the index to the, or the add, no, we will move 4 by multiplying the index to the first array. Okay, so let's create a counter, and we will use the counter as t0. This will be our counter, so let's just make it 0. Okay, we initialize the counter. Now we can do the loop, and let's call it input loop. Okay, we will run number of and okay, yes. Okay, so we start with when should we end the loop. It should end when t0, which is the counter, gets to the value of s0. So branch if equal between t0 and s0 to a place that I will call end input. Okay, and I will put it, I don't know, here. Okay, this checks if we ended getting the input for all the elements from the user. Okay, just when we stop doing the loop. Now let's tell the user prompt a insert value to the current element, and I want to tell the user what element we are using now. So let's start with doing a print a string, which is the second prompt, which tell the user enter element, and we need to insert here which element, and then doing the colon, and then the user will enter something. So here we'll just prompt load address for 10.0, the address of prompt 2. Okay, and then syscall. So we are now telling the user enter element. Now we need to tell him which element. um, Maybe okay, wait a sec. Okay, so enter element, and now we need to tell him which element. So we need to print an integer. So let's print the integer of the current element number. So use li with v0 of 1 because we want to print an integer. Now, which integer? How we know? We'll use the counter. The counter counts which element we use, right? And let's do it like in computer science. So the first element will be 0. So let's move to, we will print using a0, and we need the counters, and the counter is t0, and then we do syscall to print the integer in a0, right? Right. Now we continue by printing the colon. Yes, so if you look until now, what happens, just that we understand, I have to enter the number of elements, let's say 5. Now it tells me enter element number 0, and that's it, because we didn't jump again to the loop. But you can see that we are starting with element number 0. Now I'll do the colon, and then I can tell the user which element we are working at now. So let's tell him that this is the number, and now let's print the colon, and this will be a0 colon and syscall. Okay, let's call it print. Okay, now great. Now when you look at this, you will see that I have the colon here. Great. Now I need to do it in a loop. Just a sec. Okay, so I need to do it in a loop, and before I'm doing the loop, I need to read the integer, right? I'm telling the user to enter an element. I need to read the integer and then store it in the right place of the array. So I need to read now the integer, and to read the integer we'll use reading an integer, which is v0 of 5. So we'll do li v0 of 5 and syscall, and now I can read the integer from the user. The next thing that I will do is store the integer, because if you look now, what I'm doing is 5. Now it tells me here, now I can read an integer, let's say, I don't know, 2, and now I need to store this in the array, because now I don't have storing, so this is not good. I need to store it in the array, so let's store it in the array, and let's store the integer in the array, in the right place of the array. So we need to know where to place it, in the right place of the array. So we need to use offset. Now the offset will be used using the counter, because I know the counter tells me how many bytes I use, how many cells of the array I use, and now just multiply the counter by 4, because each moving is like 4 bytes. So if I'm counting to 2, namely 2 loops, I need to move 8 bytes. So what I will do is, we start with 0, so the first one will be 4 times 0, which is 0, so we'll put it in the start of the array. When the counter will get to 1, we need to move 1 times 4, which is 4 bytes forward. This is the second cell, and in the next loop the counter will be 2, so we'll move 2 times cells, namely 4 times 2, because each cell is 4 bytes. So this is the idea. We need to move 4 times time the counter. So in order to go to the address, I'll use array and in parentheses how much I need to move from the base. So I will make what I want now to do is to use a register, some register. Let's take T1. I'm just doing in comment. I want to tell you what I want to do. I want T1, which will be T0, which is the counter, times 4. Now this can be done using shift left logic. If I'm taking shift left logic of a binary number, like I don't know, this, and if I'm doing shift left logic of 2, shift left logic 2 of this, what will happen? What will happen is that it will become 0 1 0 0, but I changed it from 1 to 4. So shift left logic of 2, it just multiply my number by 4, and this is exactly what I need. So I will do this. I will use shift left logic in order to multiply by 4, and I will store this value in T1, as I don't want to change the counter. I just use the counter, multiply it by 4, and use this as the new address, multiplying the base address of the array and moving 4 times counter bytes forward. So let's do SLL. We will insert it into T1, and we will take the counter, which is T0, and move it by 2, shift left logic 2, which is like multiply by 4 the counter value in T0. Okay, this is just in order to move so I can move in the array the number of cells I need. If the counter is 2, I need to move to be on the third cell in the array. Okay, so the next thing I will do is store now the value that I have. Where is the value that I got from the user to the current integer? It's right over here in V0. So let's save word. So I will save V0 into array, but where? In T1, because T1 will tell me how much bytes I need to go forward based on the counter. Take the counter, multiply it by 4, this will be T1. T1 will tell you how much to move forward in the array. So here let's call it save the current element value from the user in the right place in the array. Okay? Great, so we got a number, we told the user which element we are in, we printed for the user the message, we got the value from the user, and we inserted the value to the array. Now what we are going to do is we are finished. So we now should just we're finished with this. So with this loop, so we need to increment the counter. So increment the counter. Counter, remember, is the T0 of us. Okay, so let's add 1 to the counter. Note that I add 1 to the counter because it's just counter of numbers. So let's just add 1, and now just return the loop. Add 1 to the counter. And now let's just jump to the loop, input loop. Okay, so let's jump to the input loop. Now we're jumping again until we are getting to the point in which the counter equals the length of the array, which is in S0. Until then we are printing the user the number, the enter number we are at, and then we getting it from the user, reading the integer into V0, and knowing where to put it in the array, putting the value that we got from the user into the array in the right place, and then incrementing the counter by 1 and returning and doing the loop again and again until we get to this and ending the input and going to here. And we'll see what we need to do when we end the okay. Now when we will end the input, we will have an array with numbers. We will need, I had another goal to the program, not just to get values from the user and insert it to the array, but also to sum the values of the array. Okay, so let's just make a pause and see what we have got until now. So what we've got until now, if we run the program, so it tells me, tell me what size, how many elements in the array until 100. So let's tell him 5. Now it tells me enter element number 0, which will say 2. Enter element number 1, 4. Enter element number 2, 6. Number 3, 8. Number 4, 10. And this is the 5th one because we started to count from 0 and then we finish. So until now what we did is also only got numbers from the user and insert it into the array. And now when end input, namely we finished loading numbers to the array from the user. Now what we're going to do, let's sum the numbers from the array. This is what we're going to do here. Okay. We will do it in a procedure inside it, so this is not exactly what it's going to do. So let's start by loading the array itself to a variable, to register. We are going to call a procedure, so we need to give the array as an argument by register, and arguments to a procedure usually are sent by or defined as A0 to A3, so the pointer to the array will be A3, so here it is, A0, so here it is, so this load the address. Now A0 points to the address of the array, to the first cell, let's say. Okay. Another argument that I want to send to the program is the number of elements in the array, and I know that because if you remember, the first thing that we ask the user is how many elements do you want in the array, and we save this value to the register named S0. So we want to send those arguments in, again, registers number or registers A0 to A1. So let's move to A1 the value in S0. A1 now has the number of elements in the array, which is S0. Okay. Now, after we finished it, we can jump and link, so we can return here to a procedure count and sum. So also, okay, now the procedure count and sum. Okay, so this procedure will have counters, and as you can see, I will tell the user what is the number of elements and the sum of elements. So again, we will count, even though we know the result. The result will be S0, which is 5. But okay, let's do it as part of the problem that we need to solve. Okay, so if you remember which registers are used to return values from a procedure, the registers that should be used are V0 and V1. So let's use them as the counters and sums. So let's start with defining them, initializing them to 0. We initialize both of them, so L0 and L1 will be used initialization, let's call it. Initialization of both of them. This will be the count, this will be the sum, so V1 is a sum, and we will need a loop counter, let's call it T0, which is 0, which will be loop counter. And now let's do count loop, which will count and sum the values in the array. Count loop, and we need to count it. We need this count. Okay. Okay. So let's count it. Until when we will count? Until we're getting to, okay, branch if equal, when to stop? When your counter T0 gets to the value of A1, because A1 has the value of the number of elements in the array. So continue the loop until you are getting to A1. T0 is the counter. So we'll go to end count. In end count, we will just jump again to where we left off, to here. And so let's do it. End count, and what we'll do in end count is jump to RA. Okay, which is return to color if you want to return to color. Okay, so let's call it check if we ended the loop, which means that T0 equals A1 which is S0, which is the number of elements in the array. Okay, so okay, if we didn't finish the loop, if we try this if and it's not true, namely we didn't finish the loop, so we need to count and we need to sum. Okay, so we need to count and we need to sum. So in order to sum, we need to load the value from the current. We need to run on the array and we need to load it. We need to load which element is the pointer to the array, what is the pointer to the array, A0, and what will sum let's just, okay, we'll use these two in order to get, just to load the value that we are at now. A0 is the pointer, and we are getting the value at the pointer to T2. So T2 will have the value of the current value in the array. So let's call it load the current value of the array, which A0 points to T2. So T2 holds the current value of the array using load word. And now let's update count and sum. Now remember that count is v0 and sum is v1. So count, I will just add 1. So add 1 to counter. It's like v0 plus plus, or v0 v0 plus 1, whatever you want. And to v0 I need to sum, so I'll do add v1 and I will add the value t2, right? Add to the sum, which is v1, the current value from the array. Okay, now after we counted this one and we summed this element, I need to move forward. And remember that moving forward in an array of integers means moving 4 bytes forward. So I need to move a0 4 bytes forward. So let's move it. Add I, and let's take the pointer to the array and move it 4 bytes. Move the pointer of the array to the next cell, which equals 4 bytes forward. Okay, this is move to the next element. Okay, and we need to continue the loop in order to end it sometime. So let's increment, add immediate, increment the counter by 1, and let's jump again to the count loop. Okay, when we end the input we will exit. I want to exit in the end of the input. Okay, you know what, let's leave it so I will know when to end. I just want to end the program somewhere now, exit, in order that we won't get to a infinite loop. So let's just again do it. So somewhere, somehow we will exit the program. Okay, so we ended it, we summed it up, we have the values, and the values now, remember that the values now, this is the value for the counter, the number of elements, even though we know that in S0, but okay, we counted anywhere. We counted the number of cells in the array, we counted the number of elements, the cells with elements from the user in the array, and we summed all the values of the array that the user inputted. And now those are the return values from the procedure. Now we need to go back to when we are finished, we need to end count, which we'll get here if we finish the loop, and we get back to where we came from, which is this where. Okay, so we are pretty much almost finished. I'm pretty much going to print now all the results because we got now everything we need. We just need to print it. Now remember that the returning values are in v0 and v1. Now we need v0. v0 is the register for syscall, so we are going to change it. So let's just save the values we got back in registers. Let's take S0 and S0 is already taken, so let's take, because it's the number of elements, let's take S1, S2. So let's move the values to S1. Let's move the counting, for example. So V0 is the counter, count number of elements in array. This is S1 now. move to S2 the sum is in V1, so sum of elements in the array. Okay, now we need to print the results. I mean, we have everything we need, we just need to print it. Okay, so now let's print what we're going to print first. Print results, and we'll print the count. So let's print the count. Let's print a message. So load immediate v0. We want to print string. So load address to a0. We want to print which prompt? Result 1. Result 1 syscall. Now it will print, and now we want to print the number. So print the number of count, which is s1. So li of v0, in order to print an integer we need to print 1. So we need to move to a0 s1 because we want to print the integer. Yes, and now let's just print it. So now I can tell you what is the count, how many elements are in the array. And if you look at it, if you clear and look, so I tell him 5 elements, 2, 4, 6, 8, 10, and oh my god, wait, 94. It tells me that there is a problem in this one. So let's see if I made a mistake here, because probably I did. In the count, runtime exception at fetch address not aligned on word boundary. Oh, maybe it's because I need to finish it, because when I'm finishing it continues to do it again when I should not do it. So let's do a syscall that will end it. Exit the program here because I don't want to do it again. Li of v0 should get 10, and then syscall, and that's it. Let's do it now. 5 elements, 1, 2, 3, 4, 5. Okay, now it's good. Because what happened is that we did this, we ended it, we came back to here, and then we came back to here. And then he got here, but we are going too far. So, and we're fetching to a0 something that is not even as should. I mean, I should move here by number of 4. Okay, so we printed the count. Now we want to print the sum. So we printed the count. Now we want to print the sum. So let's just print message for sum, which will be like this, which is li v0, and I want to print a message, and la to a0 I want to print a message result 2 and syscall. So this will print the sum is. Now let's print the value. Now li v0. Now to print the value integer is 1, and I want to move the sum. So I want to print in the sum is in S2 if you remember. So then go syscall, and this is printing the message, and this prints the sum. Now if I do it, now I think I'm finished. Let's see. 5 elements, 2, 4, 6, 8, 10. Great, I have number of elements 5 and sum of elements 2 plus 4 plus 6 plus 8 plus 10 is really 30. So again, it's summed as it should. Great work. It did work. So let's sum it. So the idea was how to work with arrays in MIPS, especially arrays of integers. So what we did, and the idea of this was to create an array, tell the user to tell me how long the array is until some boundary, and the user should insert values to the array. I should put it inside the array, working with addresses. Then after I insert it to the array, I needed to count the number of elements, even though I know that, and I need to sum them all up. And you saw how I worked with the array and moved, and how we worked with the parameters of the procedures and the return values of the procedures. So we defined array, defined prompts and got numbers from the user until we are finished to read all the numbers it told us. Then we went to count and sum the values in the array, and then we got to just take in the return values of the sum and the count and print them all out and exit the program, because if we won't exit, it will do very bad things, as you saw. So thank you very much. This was using MIPS to work with arrays of numbers. Remember that each cell is 32 bits because it's an array of integers, of words. So note that. Thank you very much. If there are any mistakes or correction, I'm sorry, and please leave a comment below. And thank you very much. This was MIPS programming, working with arrays, especially arrays of integers, and getting numbers from the user, summing them, and working with it, with the addresses. Don't forget. That's it. That's it.